This is a scanning electron microscope image of the MXene titanium carbide. MXenes are two-dimensional inorganic compounds of transition metals with nonmetals like carbon or nitrogen. They have interesting properties that are tunable. MXenes are synthesized by the top-down selective etching process of MAX phases. The A layer consists of elements like aluminium, silicon, zinc, or gallium, shown in gray color in this picture. It is removed with a solution of hydrogen fluoride or a mixture of hydrochloric acid and lithium fluoride. Another MXene synthesis method is the reaction with Lewis acid molten salts, for example zinc chloride. MXenes can also be synthesized by chemical vapor deposition, CVD. One example is the compound tungsten nitride. This method is scalable to wafer size and is interesting for applications in electronics. The properties of MXenes depend on the lateral flake size. Exfoliation techniques, for example sonication, can reduce the flake size down to nanometer scale. This picture is of the exfoliation of titanium, silicon, and carbon monolayer on a copper substrate. The forces between the MXene layers are weak. That allows the intercalation of molecules like urea or ions like lithium. MXenes could be used as electrode material for lithium and sodium ion batteries. MXene clay can be produced by pre-intercalation of dimethyl sulfoxide, DMSO, and etching with hydrochloric acid and lithium fluoride. It can be used for energy storage. MXene monolayers have many electrons at the Fermi level. They are predicted to be metallic. The electronic properties are tunable by doping and by creating vacancy centers. Structural and electronic properties can be tuned by covalent surface modification, for example with halogenides, oxygen, sulfur, and selenium. The surface groups can induce a big strain in the MXene lattice, and they have an impact on the magnetism of the material. Titanium nitride and sulfur functionalized niobium carbide are superconductors. Their critical temperature is at 6 Kelvin. A thin film titanium nitride superinsulator was created by cooling down to near absolute zero. Titanium carbide MXene is a ceramic material. The flakes that look like flowers are stiffer than steel and conduct electricity. These flakes were dried at -50 degrees Celsius. This image was taken with an electron microscope at 1 micron scale. This picture shows a MXene polymer composite material. The composites have a tensile strength of up to 4 times that of pure MXene. They can be incorporated into conventional fabrics. This diagram shows the exponential growth in the number of patent families in red and non-patent publications in blue over the last 15 years. The y-axis is logarithmic. It is very likely that MXenes will be used in some everyday products in the future. This image shows the conducting domain walls of a MXene image by Kelvin probe force microscopy, a surface potential microscopy method. You can check out the links to the scientific articles, and you can check out my other videos from the series Fascinating Nanotechnology. Thank you for watching. Bye bye.